a function. This is 25a, and it looks like that. And that's my x-axis, and that's my y-axis. And they want you to sketch the graph of a derivative function. So the slope here is 0. That means the derivative has to be 0. So it is going to be on the x-axis. So this is going to be, this is my f of x. That line there is going to be f prime of x. B. Okay, you have a line, and this is, they tell you this is 30 degrees. And you have another line here, and they say this is 45 degrees. Okay, let me redraw that so I can accentuate that a little bit more. So it says 45 degrees. Right, they want you, this is my f of x, this is my y-axis, and this is my x-axis. They want me to sketch the derivative of this. Okay, the slope here is negative. That means the derivative is below the x-axis. Okay, there's a corner there, so that means the derivative does not exist. And then the slope here is steeper negative. That means the derivative is going to be even smaller than that, so it's going to be down here. Still open circle there, so that will look like that. So this is my derivative curve based on the slope of the original function. And then finally in C, I have a Wolverine curve, and it looks like this. Okay, this is my f of x, it's my y-axis, and this is my x-axis. We're graphing the slope of this function. The slope here is 0, slope here is 0, slope here is 0. That means it's my derivative curve will cross the x-axis here, here, and here. So these three places where it crosses the x-axis. So we're going to put some dots right there. The slope here is negative. That means my derivative is below the x-axis. The slope here is positive. That means my derivative is above x-axis. Okay, and then slope is 0. And the slope here is negative. That means the derivative is below the x-axis. Okay, and then it's 0 again. And then slope here is positive, so that means the derivative is going to be above x-axis. So this is my f prime of x. Alright, what we have left is one section, which is limits. So let's take a look at that. Limits of trigonometric functions. And that's page 163. Page 163. Page 163, we're starting with 11. Okay. And then we go to 17, 15, and 19. Those are only teens. Okay, so let's start with 11. Okay, number 11. Number 11. A, okay, they give you a function sine of x to the third, okay, plus 7x plus 1. Okay, they want you to break this up into two functions, okay, because this is a composite function. So if you call f of x is equal to x to the third, okay, and then plus 7x plus 1, and then if you call g of x is equal to sine of x, of course this would be the composite function g of f of x. So we're going backwards. We're going to split the composite function up into two different functions that are continuous. So in B, you're given absolute value of sine of x. This is my g of f of x, or you can call it f of g of x. It doesn't really matter. Okay, so I'm going to call my g of x is absolute value of x. I'll call my f of x is equal to sine of x. And that will work. When you combine these two functions, you'll get that. Okay, C. Okay, C, you're given cosine cubed of x plus 1. Let's say that is, let's call this one other way. Let's go f of g of x. Okay, then my outside function is f of x, which I can call that cosine cubed of x, and call now g of x to be x plus 1, and when I combine these two, I'll get that. D. Okay, I have a square root of a 3 plus 2 plus sine of 2x, not 2. So square root of 3 plus sine of 2x. So if that's my f of g of x, of course my outside function f of x can be represented using square root of x, and g of x, which is my inside function, can be representing 3 plus sine of 2x. Let's keep going. Okay, let me erase this. Let's try again. Alright, so I'm at 11 E, and that's given sine of x. If this is f of g of x, okay, then you're going to call f of x is equal to sine of x, and you're going to call g of x is equal to sine of x, and then we're going to put that in. Alright. F. I have a cosine 5th power x minus 2 cosine cubed of x plus 1, and if I call that f of g of x, okay, then I can call my f of x function as x to the 5th minus 2x to the 3rd plus 1, and my g of x function can then be cosine of x, and when I put this in here, okay, it will look like that. Okay, that's it for 11. So let's go to 15. Okay, 15, I'm finding a limit as x goes to positive infinity. Okay, sine of pi x, all that over 2 minus 3x. Okay, this is a composite function. That means I can go inside and take the limit as x goes to positive infinity of pi of x, all that over 2 minus 3 of x. And when I take a limit of that, okay, since the powers match up on top and the bottom, it's going to leading coefficient, which is negative pi over 3. And then when I take sine of negative pi over 3, we get negative rad 3 over 2. Okay, 17 and 19. Okay, 17. I have a limit as, let's use x. X goes to 0, sine of 3x over x. I can't use a theorem unless I put a 3 here, but if I put a 3 there, I'll have to put a 3 up here to undo that. Now I know according to my theorem, that goes to 1. 1 times 3 is going to give me 3. And number 19. Okay, limit as x goes to 0 from the left side, I have a sine of x over absolute value of x. Okay, so whenever I have absolute value, it really is a short way of having two things. That means this could be either negative x or it could be positive x. Since I'm coming from the left, my x values are going to be negative, so I can rewrite this as limit as x goes to 0 from the left side, sine of x over negative x. Okay, so I know this part here is going to go to 1, so times negative 1 is going to go to negative 1. That brings us to the problems in 20s. Okay, so alright, so what I need here is I see 23. I see 25. I see 27. Okay, that's it. So 23. 23, I have a limit as x goes to 0, tangent of 7x, all that over sine of 3x. Right? I have to do some algebra to manipulate this. This same thing as a limit as x goes to 0. That is sine of 7x over cosine of 7x. All that over sine of 3x, which is same thing as a limit as x goes to 0, sine of 7x, okay, over cosine of 7x, and this is really over 1, and this is a division sign, so that flips, so I'm going to get 1 over sine of 3x. Now, I can rewrite this as limit as x goes to 0. I get sine of 7x over something times something over 1 over cosine of 7x, and then I have minus or times 1 over sine of 3x. If I want to use my theorem, I need 7x here. I can use my theorem. If I want to use my theorem, I need a 3x here. Of course, this x and this x cancel each other out, but I can't do anything about the 3 and the 7, so I have to adjust for that. So I'm going to put 7 over 3 out in the front now. If I adjust it for my 7x and 3x, according to the theorem, that's going to go to 1. This is going to go to 1, okay, because I have 3x over sine of 3x. Okay, now I can actually plug in the 0 for x there. That means 1 over cosine 0 is 1, so that's going to go to 1, so the whole thing is going to go to 7 over 3. Okay, 25. 25 says limit as h goes to 0, h over tangent of h. Again, we're going to do some algebra here. Limit as h goes to 0, h over sine of h over cosine of h. Okay, this is the same thing as limit as h goes to 0, and that's h multiplied by cosine of h over h. Okay, sine of h, because I'll have to flip this fraction. Okay, this is the same thing as a limit as h goes to 0 of h over sine of h times cosine of h. According to the theorem, that's going to go to 1, and when I plug in 0 there, that's going to go to 1, so 1 times 1 is going to give me 1. Alright, 27. Okay, 27 is a limit as x goes to 0 of x squared, all that over 1 minus cosine of x. I'm going to, if I can't figure out what to do, I'm just going to rationalize, I'll multiply the bottom by the conjugate, 1 plus cosine of x. This will give me limit as x goes to 0. The denominator is difference of two squares, 1 minus cosine squared of x. And then top I have a x squared times 1 plus cosine of x. Okay, this is the same thing as a limit as x goes to 0, x squared over, this is a trig identity, which is a sine squared x times 1 plus cosine of x. Okay, so this is limit as x goes to 0, x over sine x times x over sine x times 1 plus cosine of x. According to the theorem, that's going to go to 1, that's going to go to 1, and this one I can actually plug in 0, so cosine of 0 is 1, so 1 plus 1 is 2. Alright, now we're into 30s, so let's see what we have in 30s. We have 3 problems in 30s, so I have 31, I have 37, I have 39. Okay, 31. This was extra credit problem. So limit, I'm going to use x, so x goes to 0. It's just easy for me to write that way. 1 minus cosine of 5x, all that over cosine of 7x minus 1. So I don't know what to do with this, because when I put in 0, I get 0, 0. So I'm going to multiply top by the conjugate, which is 1 plus cosine of 5x. So I've got to multiply the bottom by the conjugate. Same thing, which is 1 plus cosine of 5x. These two will take care of each other. Now this one, 7x, I don't have anything to do with that, so I'll multiply the bottom of that by the conjugate, which is cosine of 7x plus 1. So I've got to multiply top by the same thing, cosine of 7x plus 1. Okay, this times that is difference of 2 squares, and this times this is going to be difference of 2 squares, and I'm going to have this left over in the end. So if I rewrite this, it's going to give me a limit as x goes to 0. So 1 minus cosine squared of 5x, all that over cosine squared of 7x minus 1. And of course I still have cosine of 7x plus 1 over 1 plus cosine of 5x. Right, now I still can't take limit of this, but I can take limit of this because I can plug in 0. When I put in 0 here, this becomes 1, so 1 plus 1 is 2, so top becomes 2. When I put in 0 there, this becomes 1 plus 1, which is also 2, so this actually ends up going to 1. So all I have left is limit as x goes to 0, 1 minus cosine squared 5x over cosine squared 7x minus 1. This is a trig identity, and that's going to be sine squared of 5x. Well, if this was reversed, it would be a trig identity if they're opposite of each other. So I can actually factor out a negative, write that as a 1 minus negative times quantity 1 minus cosine squared of 7x. Now I can make a substitution there, so better write limit x goes to 0. So limit as x goes to 0. See this negative sign? I can pull that out in the front, so just get it out of the way for right now. Okay, and then I have a sine squared of 5x, and then the bottom here is a trig identity, which is sine squared of 7x. So sine squared of 7x. Okay, I have a negative limit as x goes to 0, and I'm going to split this up as a sine squared of 5x, all that over something, and then times something over sine squared of 7x. Well, I have two of these, so that means I need a 7x times 7x here, so I can split this up and make this one go to 1. And I got two of these here because I have sine 5x times sine 5x. I need a 5x and a 5x. Okay, the x's cancel each other out. I got 2x on the top, 2x on the bottom. But this 5 times 5, 25 on the bottom. Okay, and then 7 times 7, which is 49 on the top. Okay, that gives me a problem, so I have to adjust for that. So I'm going to put 25 over 49. Okay, and since that's a constant, I can pull that out. And this is now going to 1, and this is going to 1. So the whole thing goes to negative 25 over 49. Okay, 37. 37, 39. So this is 37. In 37, limit as x goes to 2. I have a sine of quantity 2x minus 4, all that over x squared minus 4. Okay, so I'm going to split this up, limit as x goes to 0. Okay, I'm going to have a sine of 2 times x minus 2, all that over, this is factored form, x minus 2, x plus 2. Okay, I have to match up what's inside the brackets at the bottom. So what I'm going to do is I'm going to slide the x plus 2 to the side, and I'm going to put 2 out in the front so I can match up. So this now looks like limit as x goes to 0, sine of 2 times x minus 2, all that over 2 times x minus 2, and times x plus 2. Because I put the 2 here, I have to put 2 on the top. Alright, now we can actually plug in a value 0 for that one, so this part here is going to go to 2 over 2, which is equal to 1. Okay, according to my theorem, since this matches up with this, and when x goes to 0, this whole thing here goes to 0, and this whole inside there goes to 0, so my theorem says this whole quantity here goes to 1, so that's going to go to 1. Last one, 39. Okay, in 39 I have a limit as x goes to -1. Okay, and then I have a sine of x squared plus 3x plus 2, all that over x to the third plus 1. Okay, this is limit as x goes to -1. Okay, and then I'm going to factor the top. Okay, and I'm going to get sine of x plus 2 times x plus 1. Okay, and in the bottom I'm going to factor that, and that's going to be x plus 1 times x squared minus x plus 1. Okay, I have to match up with that on the bottom. I have that part. I'm going to slide this over. Okay, I'm going to try to match up. So limit as x goes to -1, have a sine of x plus 2 times x plus 1, and then in the bottom I have an x plus 1. Okay, and then I need an x plus 2. Okay, but if I put an x plus 2 on the bottom, I'm going to put an x plus 2 on the top, and I still have this trinomial here, x squared minus x plus 1. Okay, let's go ahead and take a limit. So when I put in -1 there, the top's going to go to 1. When I put in -1 here and here, okay, it's going to become 1 plus 1 plus 1, so bottom's going to go to 3. Okay, and of course, according to my theorem, since this matches up with this, as x goes to -1, the bottom goes to 0, the top's going to go to 0, so this is going to go to 1. So the whole thing is going to go be 1 times 1/3, which is 1/3. Alright, now we're into the 40s. Okay, so what we have in 40, we have 41. This is the last set of problems. We have 41. We have 43, A, B, and C, looks like. 43, A, B, and C. Okay, let's take a look at 41. 41. They want you to find a non-zero value for constant k that makes the function continuous. It's a piecewise function. This is f of x is equal to tan of kx over x, and that's when x is less than 0. And then I have a 3x plus 2k squared when x is greater than or equal to 0. Okay, we want to make it continuous. So to make it continuous, the y value here and here have to be the same, but I can't plug it in, so I have to take a limit. So limit as x goes to 0 of tan of kx over x. If I have k right here, then this is going to go to 1, but I can't just randomly put k, so I have to put k out in the front. Now I can take a limit of that, and I'm sorry, this is coming from the left. That's why I have to use the top function. Okay, and this is going to go to 1, so 1 times k, that's going to go to k. Then when I take a limit as x goes to 0, from the right side, I'm using 3x plus 2k squared. Okay, and then when I take a limit of that, this is going to go to 2k squared. The only way this could be true is these two values are exactly the same. Okay, that means that I'm going to set k is equal to 2k squared, and that means 0 is equal to 2k squared minus k, and then when I factor out a k, that'll give me 2k minus 1. So I get two solutions, k is equal to 0 and k is equal to 1/2. since they told me non-zero solution, k is equal to 1/2. So if this was 1/2, and if this was 1/2, then these two will be connected. Okay. So 43, A, B, and C. So 43A. 43A, I have a limit as x goes to positive infinity of x times sine of 1 over x, and they actually give you a hint. They say t is equal to 1 over x. So we're going to make the substitution. Okay, so limit as x goes to positive infinity, have x times sine of t. Of course, I'm going to start writing everything in terms of t. So when I solve this for x, the x turns out to be 1 over t. So I'm going to make that substitution, 1 over t times sine of t. And of course, when x goes to infinity, that means when this gets really big, then the whole thing 1 over x is going to go to 0, and that means t is going to 0. So I can write this as a limit as t goes to 0. Well, that same thing as limit as t goes to 0 of sine of t over t, and that's equal to 1. Alright, let's go with b. Alright, in b, I have a limit as x goes to negative infinity. X times quantity 1 minus cosine of 1 over x, and they give me a hint here, and they tell me to let my t is equal to 1 over x. Okay, let's punch in what we have right now. Okay, just like last time, I have a limit. Okay, I'm going to take, when x goes to infinity, that means this gets really big. T is going to go to 0, so I can write t is going to 0. Of course, x, when you solve for x on this one, this will turn into x is equal to 1 over t. So I'm going to replace x with 1 over t. Okay, and then I have 1 minus cosine of t. Okay, and this is the same thing as limit as t goes to 0, 1 minus cosine of t over t. Okay, so now what we can do is we can look at the theorem. We have a theorem for this. Okay, and this theorem says that's going to go to 0. Okay, that's on page 160. Last one. Okay, the most interesting one. Okay, this is 43C. I have a limit as x goes to pi, and that is pi minus x, all that over sine of x. Okay, and then I have a t is equal to pi minus x. So they want me to substitute that in, so I'm going to plug it in. So I have a limit. Okay, this now becomes t on the top. Of course, and when I solve this for x, I'm going to switch these two. That's going to give me x is equal to pi minus t. Okay, so I'm going to write sine of pi minus t. Okay, as x goes to pi, when that turns into pi, the t is going to go to 0, so I'm going to have t is going to 0. Once I get here, I have to, oops, not x, it's a t. Once I get there, I have to remember my trig identity, sum and difference formula. Okay, I have a t. My sum and difference formula for this is going to be sine of pi times cosine of t, okay, minus cosine of pi times sine of t. Alright, sine of pi is 0, so that means that's going to go away for me. And then I have a minus, cosine of pi is negative 1. Then the two negatives here will become positive. So what I have now, this simplifies to limit as t goes to 0, t over sine of t, which is going to go to 1. That's it. That's all the problems.